Matthew, so I got your email that you're having problems with project 1.12 about repMult. So let's take a look first before we look at that one, because there are some related ones on that page, the factorial and the power functions. But before you even do that, let me just show you this site that I just found a little while ago. I think it's really helpful. It's one I used for doing the examples I sent you the last time. It's called pythontutor.com, and it lets you actually run these run programs online. So I'm going to get rid of actually the code that's in here. That's not what I want, and I'm going to step through. So here's the factorial and the power functions from the Chapter 1 document that you have. So I'm going to take a look at these first. So here's the definition of factorial, and just make sure that we have, because recursion is really tricky. So I just want to make sure that that makes sense how that's working. So I'm going to click on Visualize Execution here. Oh, you know what? Before I do that, I have to put in a call so we can actually run through it and see how it works. So I'm going to say factorial 4, let's say. And then I'll say Visualize Execution. So what's happening, if you watched the Sigma and the video on Sigma and Prod, you see what's going to happen here is that we're going to step through, and first it's going to make this global variable factorial, which it does right here, and then we're going to do an actual call. So in light green is the line we just executed, and red is the line that we're going to do next. So let's step forward, and now we'll actually go into the function. Okay, and at this point n is 4 because we called it. We passed 4 as the parameter. Okay, so then we go forward, because so n was not equal to 0, so we go straight to this return statement here. So it says return n times factorial of n minus 1. So it's going to be n is 4, so it's going to be 4 times factorial n minus 1. Well, you know that factorial is this function. So when we make the next step, now n minus 1, since n is 4, n minus 1 is 3. So now we're going to call factorial again, but with a 3, right? So we step through. If n equals 0, well, it doesn't. So we go through here, and now we're going to multiply. This one tells us to multiply 3 times factorial of n minus 1, which is 2. So it's factorial of 2 now. So we're going to go into factorial again, but this time with a 2. N equals 2. So now it says if n equals 0, no, it doesn't. So we're going to go through again, and then it says, okay, well, multiply n times n minus 1. Well, since this time n is 2, it's going to multiply 2 times factorial of 1. So let's see what factorial of 1 is. We go in again. So now I see now we're down here. Factorial n is 1. Is n equal to 0? No. So we go forward again. Now we're multiplying 1 times factorial of 1 minus 1, which is 0. Okay, if n equals 0, well, this time n does equal 0. So now we're going to return 1. So what happens? Well, we returned 1, and then we're going to pop back up. So now we say forward. The return value this time is 1. We actually have a return value to do something with. We pop back up here, multiply 1 times 1, because this so factorial of 1, that returns 1. So 1 times 1, that pops us back up. Or factorial of 0, I mean, returns 1. So 1 times 1. That pops us back up. So now we're back here at the one where we're working on factorial of 2. So we're back up on that one. So now we're going to multiply 2 times 1, and we're returning a 2 from here. And now we're returning a 6, because 3 times 2 is 6. So when we're coming back, we're working on factorial of 3, right? 3 times 2 is 6, so we're returning a 6 from there. And then finally 4 times that is 4 times 6 is 24. So we're going to return a 24. Okay, and that's what we ended up with, was 24. So, oh, and something else I forgot to mention in the last video is you can back these up too. You can use the slider. You can use this, back button and go to first or go to last, whatever you want to do. Okay, so it's a really nice way to kind of just look through and see what's going on. But anyway, so that's what's going on with factorial. Let's take a look at the power one and see how that one works. Actually, I think what I'm going to do is I want to, because the one on page 30, yeah, it looks more like this. Are these the same thing? Yeah, these look like they're doing this. Oh, I see. And then the set of e equals 0, return 1. Yeah, so these. Okay, so I'll let you play around with these, but for now I'm just going to step through this one. Then you can also try this one and compare the two and see how they're going differently. But for now, I just want to give you the general idea here. So I'm going to stick this in, and I'm going to say power 30a, and let's do 2 to the 3rd power. Okay, so 2 cubed is 8, right? So that should give us an 8. So let's try running that and see. So we're going through here, and we're saying, okay, the first time through, we create a global variable that points to that function. And now we're going to actually call the function. So let's see. So we go into it with n equal 2 and e equal 3. I'm going to check to see if e equals 1. No, it doesn't. So we're going through here, and we're going to call it again. And now this time, see, we called it with a 2, and 3 minus 1 is 2. So then we have n is 2 and e is 2. Okay, and go through again. And now we have, since n is 2 and e is 2, this is still going to be 2. This is going to be 2 minus 1, so this goes down to 1. Okay, and yeah, so now we have 2 and 1. If e equals 1, we return n. So e does equal 1 this time. So we're just going to return what our n is. Our n is 2. And now we have a return value of 2. So we're actually returning something. So when we pop up, we're going to have 2 times 2. That's 4. And then we're going to, now we can return from this one. And we get 2 times 4 is 8. And now we're done. Okay, so and again, like I said, you can step through these and see what's going on. But and it's helpful to compare this one with the other one too. But let's try to do let's take a look at repMult then and see what that's supposed to be about. So we know that repMult. Let's see, that's on page 31, right? Oops, I gotta go into edit code. So that's on page 31. So we're going to want to do something kind of like this. We're going to kick it back. But we know that repMult say, we know that repMult needs 3 inputs. Okay, it says we want N, D, and L. So we're going to have on our call down here, we're going to do something with N, D, and L, right? And our check here is going to be a little bit different. So let's see. It says, let me just put it down here. It says, what? Write a function that expresses the idea of repeated multiplication. Oh. With a generic what? Decrement and length. So when we did factorial, we decremented n every time, right? Because we would do like 5 times 4 times 3 times 2. When we did power, n stayed the same every time. We did 2 times 2 times 2, right? So we want to do something more generic, something that we can, we may or may not reduce n by a certain amount, and we want to decide what the length of our list is going to be. So the L here kind of takes on the role of E in the power function. Remember how, so E just counts down every time. It gets smaller and smaller and smaller. And here when it got down to 1, it would return n, or when it got down to 0, it would return a 1. Let's just say if L equals 0, we're going to return a 1. Let's just do that. And then what we want to do, so we're going to, so L is our countdown. L is like, has the role that E played in the power one. And then D, it says, what does it say about D? Well, it says we're going to subtract some multiple of D from n every time. So D kind of plays the role in, let me bring these up for a second. So in power, remember, so here's, here's the version where E goes down to 0. So in power, we subtract 1 from E every time, and that tells us how far to go, how many multiplications we're going to do, basically. And that's the L, or how long our list of multiplied numbers is. And then in factorial, notice we subtracted from n every time. But we subtracted 1 every time in factorial from n, right? But we want to be able to subtract an arbitrary amount. So we're going to subtract actually some multiple of D, whatever D is. Each time we're going to subtract some multiple of D. And it's going to be, the way we figure out what that multiple is, well, it shows in the book, it shows something like n times n minus D times n minus 2D, and so on down to n minus L minus 1 times D. Okay, but now notice what we want to do is we want to make L get smaller each time, because that's what we did with in power. That's what we did with E, right? So this is the guy that this is the variable that counts how many numbers are going to be multiplied, basically. Okay, so how many? So here we have 1, 2, 3, 4, right? And they're with some number in between. So it says how many of these numbers are going to be multiplied together. That's our L. And then our D, so notice if we keep iterating through, with different values of L each time, then we're basically going to be doing this every time, but the value of L keeps changing. So if we start out with L as 3 or 4 or something like that, then this will be 4 times D, right? But then when we subtract 1 from L, it'll be 3 times D. And then when we subtract 1 again, it'll be 2 times D. And when we subtract 1 again, it'll be 1 times D, right? And then when we subtract 1 again, it'll be 0 times D. So from N, we want to subtract L minus 1 times D. Okay? So we want to subtract L minus 1 times D. Okay? And then, what we can do to a way to test this out is to say, okay, well, for factorial, what would that mean? How would factorial work? Well, for factorial, we want D to increase by 1 every time, right? So we want to, or wait, no, we want D to be 1 every time. We want D to always be 1. So, no, I mean we want this whole expression to be 1 every time, right? Because we want to say N minus 1. So if we make let's see. So if we make L, does it tell us how to do that? If we make D be 1 and then we make L be N, then it'll go through L times. And I'll just keep. Let's try one of those. So let's say, let's try doing like 5, 1, 5, and see if that gives us 5 factorial. I kind of think it will. And then for power, we'll do try doing something like repMult 31. Like let's say again, if we want to do 2 cubed, let's try doing 2, 0. Now this time I'm saying 0 because if D is 0, it's just going to, then this whole thing will be 0, and this will just stay at N every time, right? And then 3. So, and then finally the one that they showed in the book, well, you're probably not going to want to run this through this whole thing on this website, but you can try it out on your Python in idle. Try doing 15, but you can run through a few of these just to get a feel for how it's working, and see how that one goes. Well, it might not be too bad. There's 6. It'll go 6 times, right? Because if L is 6. So this video is getting really long, so I'm going to let you go ahead and put this in. You can always pause the video and copy this down, and then so try putting this in and running visualize and stepping through it and see if that kind of makes sense what's going on.